Intro. Welcome back to our channel. Today, we're diving into a hot topic in the tech world: building an end-to-end AI pipeline. As data scientists, engineers, and organizations increasingly rely on machine learning, it becomes crucial to structure our processes efficiently. In this video, we will explore how to automate data preparation, model training, and deployment, ensuring that your AI systems are production-ready. By the end of this video, you will have a comprehensive understanding of how to streamline these processes and improve your AI project workflows. So, let's get started. Section 1: Understanding the AI pipeline. First, let's break down what we mean by an AI pipeline. An AI pipeline is a series of processes that systematically manage the lifecycle of a machine learning project. This lifecycle typically consists of several stages: data collection, data cleaning, feature engineering, model selection, training, validation, deployment, and monitoring. Each stage is interdependent, meaning that the efficiency and effectiveness of one stage can significantly impact the others. In traditional settings, these stages were often handled manually, leading to inefficiencies and increased chances for human error. However, with the right strategies, we can automate many of these processes, allowing for a smoother workflow and faster time to market for AI solutions. Section 2: Data preparation. The first phase we'll discuss is data preparation. Data is the backbone of any AI system. Without quality data, even the most advanced algorithms will struggle to perform well. Data preparation involves various tasks, such as data collection, cleaning, transforming, and feature engineering. To automate data preparation, we can leverage several tools and frameworks. One popular tool is Apache Airflow, which allows you to create workflows to manage the data pipeline. You can set up automated tasks for data extraction, transformation, and loading, ETL. For example, you might use Airflow to automate the collection of data from various sources, such as databases, APIs, or spreadsheets. Once the data is collected, the next step is cleaning. This involves handling missing values, outliers, and inconsistencies. Libraries like Pandas and Python provide functions to automate these tasks. You can write scripts that automatically check for missing values and either fill them with appropriate strategies like mean imputation or remove the rows or columns entirely. Feature engineering is another critical aspect of data preparation. It involves selecting the right features from your dataset that will help your model learn better. Tools like feature tools can help automate this process by automatically creating new features based on existing ones. This can save you significant time and improve model performance. Finally, once data is prepared, it's crucial to monitor data quality regularly. This could involve setting up automated scripts that run periodically to check the quality of the incoming data. If the data quality falls below a predefined threshold, alerts can be sent out to the relevant team members. Section 3: Model training. Once we have our data ready, the next stage is model training. This is where we choose the right algorithms and train them on our prepared dataset. The key here is automation, as manually training models can be time-consuming and inefficient. First, let's talk about model selection. Rather than manually testing different algorithms, we can automate this process using tools like AutoML frameworks. Libraries like Tpot or H2O.ai can help automate the selection of the best model for your dataset. They utilize techniques like genetic programming and hyperparameter optimization to find the best performing model. Another essential aspect of model training is hyperparameter tuning. Hyperparameters are the settings that govern the training process, and finding the right combination can significantly impact model performance. Automated hyperparameter tuning tools such as Apuna or HyperOpt can be used to streamline this process. These tools can intelligently explore the hyperparameter space and quickly converge on optimal settings for your model. Once the model is trained, it's crucial to validate its performance. This can be automated through cross-validation techniques, where the model is tested on different subsets of the data to ensure that it generalizes well. Automated evaluation metrics can also be set up to continuously assess model performance, ensuring that the model remains effective over time. Section 4: Deployment. Now that we have a trained model, the next step is deployment. Deploying machine learning models can be a complex process, but with automation, it can be made much simpler. The goal is to make your model available for use in production systems, and there are several approaches to achieving this. One popular method is to use containerization technologies like Docker. By containerizing your model, you can ensure that it runs in a consistent environment, regardless of where it's deployed. This eliminates the "it works on my machine" problem that many developers face. You can create a Docker image that contains your model and all its dependencies, making it easy to deploy across various platforms. Next, we need to consider how users will interact with the deployed model. APIs are a common way to expose machine learning models, allowing other applications to send data to the model and receive predictions. Tools like Flask or FastAPI can help create RESTful APIs quickly. Automating the API deployment process using CI/CD pipelines can help streamline updates and changes to the model. Monitoring the model in production is equally crucial. Once deployed, models can experience performance degradation due to data drift, or the statistical properties of incoming data change over time. Setting up automated monitoring systems can help detect these issues early. Tools like Prometheus or Grafana can be integrated to track performance metrics, such as response time and prediction accuracy. If the model's performance falls below a certain threshold, alerts can be triggered to notify the team. Section 5. Setting up CI/CD for AI. To tie everything together, let's discuss setting up a continuous integration and continuous deployment (CI/CD) pipeline specifically tailored for AI projects. A robust CI/CD process ensures that any changes made to the code, data, or models are automatically tested and deployed in a systematic way. First, version control is essential. Using a system like Git allows you to track changes in your codebase, including your data preparation scripts, model training code, and deployment configurations. Ensure that your data and models are also versioned, as changes to either can impact your entire pipeline. Next, set up automated testing. For every change made in your code, establish tests that check for data quality, model performance, and API functionality. If changes break any of these tests, the CI/CD system should prevent the deployment until those issues are resolved. Once tests pass, you can automate the deployment process. Using tools like Jenkins or GitHub Actions, set up workflows that automatically deploy your model to the production environment. This can include building Docker images, pushing them to a container registry, and deploying them to a cloud service like AWS, Azure, or Google Cloud. Automating the rollback process is another crucial aspect of a CI/CD pipeline. If a new model version is deployed and it underperforms, there should be a straightforward way to roll back to a previous, stable version. This can be automated using scripts that allow for quick recovery. Section 6. Conclusion. In conclusion, building an end-to-end AI pipeline involves several critical stages: data preparation, model training, and deployment. By automating these processes, you can not only save time and resources but also ensure that your AI systems are robust, scalable, and ready for production. As we have discussed, utilizing tools like Apache Airflow for data workflows, AutoML frameworks for model selection, and Docker for deployment can significantly enhance your ability to manage machine learning projects effectively. Additionally, establishing a CI/CD pipeline tailored to AI can ensure that your models remain up-to-date and perform well over time. Implementing these strategies may require an initial investment of time and resources, but the long-term benefits far outweigh these costs. A well-structured AI pipeline can lead to faster iterations, improved model performance, and ultimately, greater success for your AI initiatives. We hope this video has been informative and inspires you to streamline your AI project workflows. If you have any questions or would like to dive deeper into any of these topics, feel free to leave a comment below. Don't forget to like, subscribe, and hit the notification bell for more content on AI and machine learning. Thanks for watching, and we'll see you in the next video.